Math 111 students. We are in 6.2 today. And so I just want to jump on in. We are doing the inverse, secant, cosecant, and tangent. Secant, cosecant, and cotangent. And just like with the inverse sine, cosine, and tangent, the domain and range really matter. All right, remember that the inverse secant is a way of undoing the secant. It's a way of finding the angle if you originally know what the secant at that angle is. So it's the inverse function of finding the secant. The inverse secant, the inverse cosecant, inverse cotangent all work the same way. Their domains and ranges matter here. Their domains and ranges matter. So we're going to kind of focus in on the domains and ranges here. Remember, to find the inverse, we have to limit the domain of the original, because remember, domain of the original becomes the range of the inverse. The domain of the inverse is the range of the original, and we have to restrict the domain of the original so that the domain of the inverse doesn't become, it still passes the vertical line test, so it still is a function. And that's what causes us to restrict these domains and ranges here. All right, so find the value of an inverse, secant, cosecant, and cotangent function. All right, so let's say we're looking for the inverse secant of 1. And so really the question that we're asking here is this is going to be an angle. Okay, normally you would say the secant of some angle equals 1, and we want the inverse secant of 1, and so what we're looking for is the angle. All right, now for the inverse secant, the angle will have to be between 0 and pi, and it cannot equal pi over 2 because it's undefined there. All right, so we want to know what angle between 0 and pi has a secant of 1. And you can look out on your handy dandy cheat sheet, which I've got around here somewhere, and look under the secant column. When does it equal 1 between 0 and pi? Well, it equals 1 at 0. At 0. So you'll find that on your sheet there, okay? All right, so as long as you can keep the domain and the ranges straight, you should be okay. All right, how about cosecant, inverse cosecant of 2? All right, the theta, our angle, this is what angle has a cosecant of 2. For cosecant, its domain or range here is between negative pi over 2 and pi over 2. And so we want something in between there whose cosecant equals 2, or the reciprocal whose sine equals 1/2. All right, so you can look here between 1/2. The only theta in that interval whose cosecant is going to be positive 2 would be pi over 6. And again, you can look on your handy dandy cheat sheet here. All right. I actually think it might help you a little bit more for us to think through these, any of them. And so let's start with secant, inverse secant of 8. Let me just kind of walk you through this process, and you can use your calculator on this one. Okay. So let's switch over here to my thing here. All right. So we are finding the inverse secant of 8. All right, inverse secant, you plug in the secant, you get out the angle that would have that secant. And so the other way to think about it is that the secant of some angle is going to equal 8. All right, now let's think about it in terms of reciprocal, because you might notice if you ever do these on your calculators, you have an inverse sine, an inverse cosine, inverse tangent, but you do not have an inverse secant. Okay. So let's think about it. If the secant of theta is 8, then the cosine of that same theta is 1/8. So then we can take the inverse cosine of 1/8 And that would be the same as the inverse secant of 8. So the inverse cosine, get it right here, inverse cosine, 1 divided by 8, close my parentheses, and I get 1.44. Or let's see, round it up to 1.45. Okay. All right. Now, the next one that we were given is inverse cosecant of -2. Inverse cosecant of -2. All right. Now, inverse cosecant of -2. All right, this would be the same thing as saying that the cosecant of -2 is what angle? Or the cosecant of what angle is -2? All right, and if the cosecant is -2, then the sine is going to be -1/2. So we can then say the inverse sine of -1/2 is what angle? Okay, let me make sure you are seeing this right screen here. Well, I can't see it. All right, let's stop sharing all this. Can I share this guy and see it? Yes, okay. All right, so now we're at the inverse sine of -1/2. So inverse sine right there above the inverse sine above the sine button, -1/2. Oops. Inverse sine negative. I put the minus sign, not negative. -0.523 or -0.52. So this is the angle. And let's make sure I'm writing. I am in radian mode, and that's what they told us. So -0.52 radians. So would have an sine of -1/2. Okay. All right. So let's go back here to our PowerPoint. All right, how about they gave us the inverse cotangent of 1/5, and they're going to suggest that because the domain for cotangent is between 0 and pi, that's where what we restricted it to. They want to use cosine. In particular, this is where we start getting into the issue where the domain really matters. In this particular one, you might say, well, if I'm dealing with cotangent, shouldn't I work with tangent? And in this particular one, it does work with tangent. But if we get into a more complicated example, it will not work with cotangent because of the domain. But for this one, we can use cotangent. We can use the same line of reasoning. The inverse cotangent of 1/5, the question we're asking is what angle? This is going to equal an angle. What angle would have a cotangent of 1/5? So the cotangent of what angle is 1/5? And if you change it to tangent, this would be the tangent of what angle is the reciprocal of this is 5. And so then you can use the inverse tangent of 5, the inverse tangent of 5. And I'm going to stop with this when you get 1.37 in radians. I'm going to stop with this one because I do want to you to pay close attention for the inverse sine, cosine, and tangent in terms of domain and range, but I don't want us to have to worry about it as much on these other ones. It's just it starts to get really, really complicated as we go on. All right. So how about this? Let's is my PowerPoint. All right, let's go back here on our PowerPoint and do one more thing in this section. All right, find exact values of composite functions involving the inverse trig functions. Okay. All right, so we want the sine of the inverse tangent of 1/3, sine of inverse tangent of 1/3. All right, and here it might be helpful to you to have this mother of all cheat sheets. Okay, our mother of all cheat sheets. All right. Domain of the inverse tangent. Oh, let's see, what were we doing? We're doing sine, or we were doing inverse tangent. Domain of the inverse tangent. The domain's in negative infinity to positive infinity, but you're only going to get out between negative pi over 2 and pi over 2. All right. And that's going to be a little helpful to us. All right. So if we want to know what angle is going to have a tangent of 1/3, and we're going to limit it between negative pi over 2 and pi over 2 here. All right, so between negative pi over 2 and pi over 2, if you end up with a positive tangent, remember everybody's positive up here. Nobody except cosine's positive down here. So we're going to have to be in the first quadrant. And your theta is here drawn in the first quadrant, and your tangent's opposite over adjacent. All right. We need to go ahead and find the hypotenuse. This would be 3 squared plus 1 squared equals c squared. 9 plus 1 is 10 equals c squared. So c is the root of 10. Okay. And so now if I want to find the sine of that theta, the sine is going to be the opposite over the hypotenuse. So 1 over root 10, which I will rationalize, multiplying the top and the bottom by root 10. And I get root 10 up top over the root of 100, which is 10 in the bottom. So the sine of the inverse tangent of 1/3 is root 10 over 10. All right, the next one they gave us was I have to keep getting it to show me. Let's see. I want to end this. I want to go to this one. All right, there we go. All right, next one they wanted us to do or gave us was the cosine of the inverse sine of -1/2. The inverse sine of -1/2. And again, our range here, or the range for our output is limited between negative pi over 2 and pi over 2. So with sine and tangent, I believe it was negative pi over 2 to pi over 2. Cosine is 0 to pi. All right, so we're going to either be in the first quadrant or the fourth quadrant, because this is negative pi over 2 down here and positive pi over 2. And the sine is negative, so that means we have to be down here in the fourth quadrant. So I've drawn my triangle. There's my theta, and my theta is -1/2, so the opposite over the hypotenuse, and I need to find this other adjacent side. So -1 squared plus this other side, which is b squared, is going to equal our hypotenuse, which is 2 squared. So 1 plus b squared equals 4, b squared equals 3, and b equals the root of 3. All right, so then what is the cosine of this theta? The cosine of this theta is the adjacent, the adjacent over the hypotenuse. So it's root 3 over 2. Root 3 over 2. All right, let's do one more together. The tangent of the inverse cosine of -1/3. All right, inverse cosine, the angles are between 0 and pi. That's the restriction there. And so between 0 and pi, if we have a negative cosine, we're going to be over here in the second quadrant. So I've drawn my theta. Cosine is the adjacent over the hypotenuse. So the adjacent is -1 and the hypotenuse is 3. So let's find the other side. So a squared plus b squared, -1 squared equals 3 squared. So a squared equals, plus 1 equals 9. So a squared equals 8. And a would be 2 root 2. Root of 8 is 2 root 2. All right, so 2 root 2. So then the tangent of this would be the opposite, the 2 root 2, over the adjacent, the -1. So it's negative 2 root 2. Negative 2 root 2. All right, and that's it for 6.2. So be sure to use the Ask My Instructor button if you run into any problems. And don't forget that our keyword for today was cheetah. All right, we'll talk to you later. Bye.